Hello, welcome you in my channel Chemistry Simplified. I am Nutan Mishra, chemistry lecturer, going to simplify here atomic or point imperfections, that is the part of your solid state. Atomic or point imperfections are classified into three types: stoichiometric defects, non-stoichiometric defects, and impurity defects. Shall we see here stoichiometric defects? Stoichiometric defects, we can see, are four types. First of all, we can see here vacancy defects. Vacancy defect when some of the lattice sites in a crystalline solids are vacant. This defect arises. We can see here diagrammatic representation of this defect. The lattice, we can see here, we are making here the lattice sites. As we know, lattice is purely geometrical concept consisting of periodic arrangement of points. So some of the lattice sites are vacant. We can see here some of the lattice. Can you see here? This is the lattice I am making. So here we can show here vacancy. Okay. Vacancy. We can see here, this is the lattice. So we can see here one vacancy here, one vacancy here. So these are vacancies. This is your vacancy, and this is your about vacancy defect. So what happens? We have seen here, this is your lattice and these are vacant sites. Some of the lattice sites are vacant. This defect arises. As a result, what will happen? Density of the solid will decrease. Now we can see here. Okay, so when some of the lattice sites, some of the lattice site in a particular solid, are vacant, this defect arises, and as a result, density of the solid, density of the solid decreases. Okay, so this was about your vacancy defect. Now next we can see another type of defect, that is interstitial defect. Interstitial defect. Interstitial defect when some of the constituent particles in a particular solid occupy interstitial sites. This defect is created. We can see here diagrammatic representation. Some of the constituent particles in a particular solid occupy interstitial sites. Some of the constituent particles occupy interstitial sites. So here is the lattice. We can see here constituent particles are in the interstitial sites. So here we can mark here constituent particles in interstitial sites. Okay, because of this, what happens? Density of the solid increases when some of the constituent particles in a particular solid, in a particular solid occupy interstitial sites. As a result, density of the solid increases. We can see another type of defect, that is point defect or imperfection, is Schottky defects. We can see Schottky defects. When certain ions are missing from the lattice sites. Shall we see the lattice of a crystalline solids? So we are creating here lattice, and we will see how the ions are missing from the lattice sites. Here we can see, yes, this is the lattice of a crystalline solid. Here we are having cation, anion, then again cation, anion. We are putting here in the lattice anion, one cation we are showing. Here it is one cation is missing, then again anion. Here is your cation, here is your cation, anion, cation, and here one anion is missing. Here again anion. Here is your cation and anion. Here is cation, one anion. So here we are having your cation vacancy, and here we are having anion vacancies. This defect has been noticed by German chemist Schottky in 1930. We can see here, this is the representation of your Schottky defects lattice. This is your lattice. Here is your cation vacancy, here is your anion vacancy. Okay. when certain ions are missing from the lattice sites. The number of missing cation and anion will be equal. Number of missing cation and anion will be equal to maintain electrical neutrality. To maintain electrical neutrality. You can see here number of missing cations. So this is about your Schottky defects. Next type of stoichiometric point defects we can see Frenkel defects. So for Frenkel defects, what I am going to do in this only, I am just completing this lattice. It is your Frenkel defect. Frenkel defect. Here I am completing the lattice cation. Here we are having anion. So what happens in the Frenkel defect? Certain ions leave the lattice sites and occupy the interstitial sites. So since cation being smaller than the anion, they are having tendency, they are generally moved to the interstitial sites. So here we are having vacant lattice sites, certain ions, and it is moving to the your interstitial sites. So this is your Frenkel defects. Constituent particles in interstitial sites we are having when certain ions move or leave the interstitial sites, leave the lattice sites, side, and occupy interstitial sites. Cation being smaller, they are having tendency to move to the interstitial sites. So thanks for watching my video. Must like, subscribe and press the bell icon button. Thank you.